The sun is the primary source of all the Earth's energy. The oxygen we consume, the food we eat, the fuel we burn has all been produced by the sun's energy. This production takes place at the surface of the Earth, a surface we are rapidly changing. What happens to this desirable property when we remove its vegetation? When it rains? Equal amounts of water fall on both sections of land for the same length of time. We see that a great deal of soil has been washed away on the cleared side, very little on the covered side. These heat lamps will simulate the sun. We will continue the weather cycle, drying out both sides. Let's repeat the rain cycle. Now the dry. We continue to repeat this process, representing the passage of many months. A great deal of soil has been washed away. Rocks are exposed and water runs off rather than soaking into the ground. The covered area has considerable underground water. The cleared area has very little. The plant roots draw some of the underground water up into the leaves. The water evaporates into the air. In this way, one large tree can return about 1,000 gallons of water per day to the atmosphere. The sun heats the surface of the earth and the moist air. The warm air rises, cools, the moisture condenses, and forms raindrops. Gravity returns the drops to the earth, and the cycle continues. When rain falls in our man-made desert, the water runs off into streams and rivers, carrying soil with it. Little water is stored beneath the ground. There is no vegetation to return the underground water to the atmosphere and continue the cycle. Does technology have an answer? We can irrigate and replace nutrients washed from the soil. By using a closed water cycle in this demonstration, we can observe what happens to the water when soil additives are used. There is a gradual buildup in the water of anything we continually add to the soil, such as fertilizers, DDT, and other insecticides. Even the mineral salts present in our underground water supply are building up. Eventually, the water supply itself becomes contaminated. The result can be an ugly wasteland, loss of food crops, loss of feed for domestic and wild animals, and loss of water for the development of cities and industry. In an area of 500,000 square miles between New Delhi and Karachi, India, man's misuse of land has created a wasteland, the Rajasthan Desert. In 1500 BC, this desert was an agricultural empire. However, the normal vegetation was weakened by the increasing demands of a growing population on this area. Deserts, in general, are regions where the air is subsiding. As the air sinks, it moves to a level of higher pressure, which compresses the air. When air is compressed, it warms, and its capacity to hold moisture increases. In the Rajasthan, with the loss of its grass cover, dust was carried by winds into the air. Dust in the atmosphere increases the subsidence of air. The presence of the dust inhibits rainfall. Since the source of dust is the desert itself, the cycle becomes self-sustaining. Without the knowledge of how to control the cycle, it remains a desert. When the winds blow, the property is anything but desirable. This desirable property is being mismanaged. Some changes are past due. There are about 34.3 billion acres of land on our Earth. Let's examine the 2.3 billion acres that make up the United States. 58% of the United States is used for crop and livestock production. 22% is ungrazed forest land. 12% is desert, swamp, or tundra. 5% is wildlife refuges and parks. 3% is taken up by our cities and towns. In the United States, we have altered the surface of over 60% of our land. In changing the land, we are changing the complex biological systems of the soil and the plants and the animals. Each year, about 700 square miles of land are consumed by expanding urban areas. What happens to the temperature of the surface land and the atmosphere when we replace vegetation with hard soil? The temperature of the cleared area is 24 degrees centigrade, 2 degrees lower than the vegetation area. The air temperature is 28 degrees centigrade over the cleared area, 2 degrees higher than over the vegetation area. The light meter indicates that the same amount of light is shining on both areas. Is the same amount of light reflected back from both areas? The light meter indicates that the cleared area reflects back much more light than the growth area. The reflective characteristics of the Earth's surface are called the Earth's albedo. These surface characteristics are a factor in determining the temperature and climate of a specific area. If we increase the albedo, the reflective characteristics, we tend to lower the surface temperature. Densely built up areas like cities reflect more heat energy back to the atmosphere, much more than forests or grass-covered fields which absorb the heat energy from the sun. Man-made deserts have high reflective characteristics. Highway systems may also increase the Earth's average surface albedo. If we calculate the difference between the amount of solar energy absorbed by the Earth and the amount reflected back into space, we find that in 1 year, 1 square meter of vegetation absorbs about 68 watts. 365 square meters would absorb enough energy to light one 68-watt light bulb year-round. Most of the absorbed energy is used to evaporate water, heat the atmosphere, and drive our weather system of winds and rain. Less than 1% of the energy is used in photosynthesis. This 1% is responsible for our food, fuels, and fibers. When we increase the albedo of the Earth's surface, less solar energy is absorbed. More is reflected back to space. A decrease of a few tenths of 1% in global radiation balance might produce a radical change of climate, perhaps another ice age. The net effect of all the man-made influences on climate is not known. Increased exhaust emissions may raise the Earth's surface temperature. Jet trails may lower it. Cities create islands of heat warmer than the surrounding countryside. Misuse of land can produce man-made deserts. Thoughtless use can produce man-made eyesores. Misuse of land is becoming one of the most serious and difficult challenges to environmental quality. A bay filled in remains filled. A virgin forest cut is gone. What price an inadequate sewage system? Land use is still not guided by any agreed-upon standards. It is instead the result of competing, overlapping government agencies and programs, private and public desires and prejudices, and economic incentives. This desirable property produces the food we eat, the oxygen we breathe, and the environment we hope to enjoy. It is a limited resource. We should manage it well.